affect Android applications, and we'll see how we can reverse an Android application and find out the contents. And we'll also look at some of the mitigation techniques from actually securing ourselves from malwares that are out in the wild. So that's what we're going to do with this talk. So myself, I'm Abhishek J. A final year undergraduate student at Amrita University from Amrita. So basically I love Android. Since my 12th standard, I got my first Android device when I was in my 12th standard, and since then I've been working on custom ROMs, custom requeries, and root exploits for Android devices. So that was on the internal side, and then now it's Android security. So I'm working on the security of Android devices, both the internal side when we work with the Android operating system, and as well with the Android application security. And I play CTF as a part of Team BIOS. So Team BIOS is the cybersecurity team from Amrita University. So basically what we do is we have, the team consists of students, undergraduate students who are focusing on different areas of security like cryptography, reverse engineering, forensics, etc. And we play CTFs that are conducted by various universities across the globe. And currently we are top 1 in India actually.
So what is the key on Windows to project on the screen? So what is it? Not F8.
Windows 3.
Windows 3.
Sorry about that. I've been using Linux for almost 2 years, so I'm not really used to Windows for a long time. So yes. So yeah, we were here. So this is actually ctftime.org, where you can see the position. The first thing that is shown there is Team BIOS. So ctftime.org records all your CTF games that you play and the points you actually, the points you get in each one of the CTFs. And there are other people in our team who are researching on various other security topics as well. So the talk is going down like this. So we'll see why Android has grown out to be such a huge operating system today, and why Android security has to be a concern today. And next we'll look at some of the Android security implementations and issues related to the same. And we'll look at some of the real-world Android malwares, and we'll see how we can reverse Android applications using the tools and methodologies. And then we'll study the structure of an APK, the generic structure, how it looks, the components, etc. And we'll analyze each of the contents. Finally, we'll have a demo, and then we'll see how we can protect ourselves from the malwares and attacks. So why Android? The answer should be pretty much simple, because we can see Android devices everywhere, and that pretty much explains this particular aspect as well. So open source, that is one of the reasons, because not all the mobile operating systems are open source. We take into consideration iOS or Windows operating systems, they're not really open source. So Android is one mobile OS that is totally open to everybody. So you can build your version of Android and do more than that. And then it's user friendly, of course. You see Android devices in the hands of common people as well as geeks out there. So it's user friendly and it's actually versatile. You know, common people can use it because it's user friendly, and geeks use it because it's there's a lot you can do with it. And most use more developers. Of course, Android has one of the biggest developer forums in the world. It's called xdadevelopers.com. You might have heard about it. So there's a lot of development going on in the XDA forums. There are a lot of gifted developers who are doing a lot. They are developing custom ROMs. Those who have heard about Cysinfo, it basically started with the XDA developers. So most of the Android projects that are successful right now they basically started with the XDA. So this is the global OS market share as of July 2016. So the blue part which you see, which is 68%, is held by Android. So that pretty much explains why we should be concerned about Android security right now. So let's look at some of the Android security implementations so far. So it began with sandboxing. So if you've known sandboxing in the Linux and other operating systems, it's pretty much same here also. So sandboxing, so the processes that execute within the Dalvik virtual machine inside Android. So I said Dalvik. So Dalvik is the Java virtual machine ported for running inside devices that have less amount of RAM and less processing power. So basically, JVM was a heavier version, and we needed a smaller version of Java, the Java virtual machine, to run on smaller devices, and that's how we ported JVM to Android, and that's what we call the Dalvik. And so every process that runs inside the Android, the Dalvik will be running in its own instance, meaning so no other process executing in the Dalvik will be able to interfere with another process. So they are sandboxed, and the sharing of data between these processes will be done using IPC, which is again done in a secure environment. And Android is largely based on permissions model. So basically what happens is, if any of you have developed Android applications, or at least if you have installed Android applications from a third-party vendor other than the Play Store, you might have seen it displayed some permissions. Right? So that is how the permission model works. So basically, when a developer develops an application, he has to explicitly mention what all services that he would be using in the Android system, right? So suppose, let's take an example of Instagram. So Instagram basically allows you to post your photos online. So there are a set of things that Instagram should be having to do, like reading your SD card for your photos and then using your internet to post it online. So these are some of the permissions that has to be mentioned even before developing the application, right? So an example, so this is how we mention permissions inside Android applications. So here, for example, if you take the first one, android.permission.camera, so that is the permission that the developer wants from, so he wants to access the camera using his application. So that is how he is adding it. So we'll be mentioning these permissions inside the Android manifest.xml file. We'll be discussing it in a while. And the last one, what we have is ARM Trust Zone. So this is more like it's a hardware kind of implementation, right? So what happens is, most of the processes that we use on Android devices are based on the ARM architecture. So you might have heard about Snapdragon, MediaTek, and Broadcom, the processors, the general processors that you hear in the market. So they're all ARM based, the ARM architecture. They work on the ARM architecture, and ARM Trust Zone is an implementation wherein, so let me show you. So this is how Trust Zone works. So you have a normal world and a secure world, and in the normal world, all the user processes can execute, and in the secure world, the privileged processes can execute. And down there you have monitor mode, which actually keeps track of these activities that are going on, the processes going on, and in case there is a switch that is needed from one world to the other, the monitor mode makes sure that it happens in a secure manner. So I'm just giving you an overview of this. if you want to read more about this, you can read more about the trust zone actual implementation. So we've looked at some of the implementations so far. So are we really safe right now after all these implementations? The answer is no. Actually, we are at risk. We'll discuss why. So issues. So now let me ask you a simple question. So many of you might have installed, who have Android devices, you might have installed at least one application from a third-party vendor, meaning you might have installed an APK from an unknown source, right? How many of you have actually read all the permissions before installing the application? Each and every permissions. Okay. Maybe the percentage would be less than one, maybe probably 99% of the people, including me, do not check the permissions before installing them, and that easily becomes a target. So now taking this into consideration, now we are people who already know that these are the security issues, and still we don't consider it. Now imagine common people doing it. So they just think it's some terms and conditions, and generally what we do, accept anyway. So that's what they do generally. So that's one of the easiest targets, right? So what happened was the current issues, malwares, ransomwares, and exploits. So the first two things, malware is a malicious software that does something undesirable in our system that we don't intend the application to do. So there are a lot of malwares available, on the Android platform right now, and each day there are a lot being listed on many of the databases out there. So what happens is, so you don't check into the permissions. So let me say I have a legit application. So suppose I have Instagram, and I'm a malware author, and what I do is I inject some malicious code inside my Instagram application, and then I leave it out in a third-party site. So I don't have to worry about the certificates and checking that the Google Play Store does. So I'm uploading it to my my website. So then one of you who badly wants the APK would come, download from the third-party site, and then obviously you wouldn't check the permissions, and somehow it get in your system. And once my application is installed inside, it would be really hard for a common person to understand if there is a malware or if there is any malware activity happening inside, right? And ransomwares, we have not really seen many examples of ransomwares in Android platform, but recently we have seen 2 or 3 examples of ransomwares being affecting Android devices. So second reason. And third one, exploits. So this is largely based on, this is not what we are talking about right now, because exploits do not come in the form of packages generally. So how many of you have heard about the stage fright exploit that happened in 2015? So yes, it was a Python script, and it could actually drop a reverse shell from your device to the attacker's machine. All you need is a malformed MP4 file with a sophisticated payload infected within it. So since our talk is largely related to Android applications, we won't be looking at the exploits. So since that is another part, right? So let's look at some of the real-world Android malwares. So these are some of them. So I have taken few of them from the online databases. There are a lot of databases that are actually classifying Android malwares. So you can go check them out, and there are a lot of them, and each one of them doing something different. So here, as you can see, AccuTrack turns an Android device into a GPS tracker. And the last one, which you see, exploits the device to gain root privilege and then modifies access permission of database files. So basically what it does is it exploits, it has a root exploit, and it will install the super SU binary inside your device, and will use the same to leverage the permission, and then it will access the database files and collect information. So the biggest problem here is that these applications do not have to come as such, like AccuTrack.apk. You wouldn't find AccuTrack.apk coming in your device. So they will come in the name of something else, maybe IndianArmy.apk, because I've seen one of the applications like that. So once they're installed, they start doing their work, and you would never know, right? So since these are largely related to Android package, which is APK, let's study how the APK looks like and what happens inside the APK. Right, so APK is Android package. It's basically a simple zip file that is renamed to be .apk, right? Meaning you could use any of the archive managers to simply open up the APK and look into its contents. And Play Store, Amazon Store, Android, these are some of the trusted vendors of Android applications. The last one, which is F-Droid, is it's an open source. It largely focuses on open source applications, Android applications. So you can go check them out. And APK is generally it's a package which consists of few Java files where you put your code, resource files, your images, icons, etc. And the XML largely for the layouts, and libraries if you want to include other than Java. Say suppose you want your application to have some code that is not written in Java, suppose something like C or C++. You can include it inside your APK using custom libraries as shared objects actually. So this is the making of an APK. This is how it happens. So no matter what IDE you use, basically you will have the Android SDK running beneath it, right? So you might use the Android Studio or might use the Eclipse IDE as well for Android, but ultimately you will have the Android SDK down there. So Android SDK is what provides these tools, right? So all your Java files and your r.java, which is resources.java. I'll be explaining what resources.java does when I'll be showing you the demo. So for now, r.java and the rest of all the Java files will be compiled using Java-C, the normal Java compiler. And obviously we'll get a Java archive, an archive of Java files. And we have a program called DX, which actually compiles this jar into classes.dex. So .dex stands for Dalvik executable. We just talked about Dalvik a while ago. So Dalvik is the Java virtual machine code for Android. So the bytecode that Dalvik executes is called dex. So what happens is the jar file will be converted into classes.dex. This is a generic file actually. If you were to look into any of the Android applications out there, you would find classes.dex inside it. So basically, if you have the classes.dex file, you almost have the source. So and then you have the resources, which won't be compiled, will be put as it is. And last, you have the Android asset packaging tool, which will compile the resources, and the Android manifest.xml, where you define all the permissions and activities. And finally, you will get the app.apk. Finally, the APK will be assigned APK. So basically, Android also has this feature called digital signature. So any application that does not sign, or if it does not have a digital signature, it cannot be easily installed on an Android device. It won't be accepted, and it cannot be uploaded on any of the legit Play Store. It can't be uploaded on Play Store or Amazon App Store. Right, now let's look at some of the tools and methodologies that you can use to reverse Android apps. So APK tool, how many of you have heard about APK tool? Right. So APK tool is largely used for compiling and decompiling applications. This is on the development side because we don't really get the source code here. This is when we want to modify an Android application. We use APK tool. So suppose I have the WhatsApp APK and I don't like the green color, I want the rainbow colors. So then I can decompile it, change the colors, recompile it, and then use the application. So that is the main purpose of using APK tools. And it resolves to Smalley code. Smalley code is it's an assembler used in Android for DeX. So it will resolve to Smalley code, and it will not be able to easily modify the Smalley code. So let's look into the structure of an APK. So this is the generic structure actually. There may be slight changes depending on the vendor or the developer who develops the APK. But generally, these are the things, the contents that we see inside an Android application. So assets are all the Android asset packaging tool which we saw just now is the program that compiles all the app components into this assets. And we have the Android manifest.xml. Obviously, that is the control center actually. So where we define all our activities and the permission that the application will be using. Right. And then we have the classes.next, obviously the source package which we need the most. And resources like we talked about, the drawables, icons, values, etc. And lib, like we said, if we were to include some external libraries in some other code, say C or C++, we would have lib. We could put it in lib as a shared library. So for this we have something called NDK, Native Development Kit from Android. So and then we have the compiled resources and binaries in resources.arsc, and the meta-inf which stores the metadata and certificates. So we will look into this in the demo in detail. And Dalvik and add, we just discussed about this. JVM redefined for running on Android, and it was Dalvik until KitKat, so 4.4.4. Until then, it was we had an option to switch between Dalvik and Art. So Art is Android runtime which came by default since Android Lollipop 5.0, and Art there was some issue with Dalvik because Dalvik was a just-in-time compiler, meaning it compiled by running the code it would call the methods, wherein in Art, which we use right now in most of the Android devices, it uses ahead of time compilation, which means while installing the application itself, the OS creates the bytecode for that particular application, and whenever there is a need, you just have to refer the bytecode and execute it. So that pretty much helps in making it faster. The execution becomes faster because you don't have to compile the whole thing again and again. So Dex, Dalvik executable, like we talked, it's the Dalvik's code. It's the Dalvik's bytecode on which Dalvik executes, and it's basically Java classes. And Dex is easy to debug. We'll be seeing it. And some of the tools, we'll be discussing some of the tools. ADB, most of you might have heard about Android Debug Bridge. It's a tool that comes within the Android SDK. So it's helpful in moving files from and to your Android device. You can also access partitions. Suppose you want to boot in your bootloader or boot in your recovery partition, then you can use ADB. And it also helps in dropping shells. You can have a shell inside your Android device. So, and it also helps in installing applications. So, why am I mentioning this tool here? So, why is it important when we take reversing into consideration? So, the point is, when we have an APK and we are not sure what kind of APK it is, and like we are not sure what it is going to do inside the machines, and it's not always safe to install it within our devices, the physical devices. So in that case, what we do is we have the Android emulators provided by the Android SDK, and we install these applications into the emulators. For that, we need ADB. So another tool which we need is Dex2Jar. So we have talked about APK tool, which decompiles applications for modification purposes. Now, in case you would need the source code from the application, in that case, you will have to decompile the classes.dex file into something that we can read, right? For that, what we need, we have this tool called Dex2Jar. It's an open source tool and easily available. And it's small in size, works on most of all the platforms as well. And it, like the name says, it extracts the Dex to Jar. So you get a Java archive, and once you get the Java archive, obviously it is easy to use one of the Java decompilers to view the source code. So let's so we have a demo here. So here I have toasterbot.apk. So this is an APK which I got from PyCo CTF 2014. So PyCo CTF is a It's a CTF platform, Jeopardy CTF platform. So where you can actually where you find a lot of problems on cybersecurity topics. So here, this one was called toasterbot.apk. And now what we are going to do is, so there is something hidden in this particular application, and we need to find it out. So let's find out. Let's try. So I have the toasterbot.apk right now. So now I actually do not know what exactly this APK is going to do. So what I'm going to do is I'm going to install this particular application on my emulator. So for that I'll have to, so this is my emulator here. It's the Nexus 4 running on 5.1.1. So ADB installed, so this is where ADB comes into action. So we have ADB installed, toasterbot.apk. And I get a success message which says the application has been installed into my emulator. So yes, here I have the application. So let's open it up. Okay, we have a button called deploy toaster, and when I click on it, okay, I get a toast message. So this is what we call a toast message in Android. It just pops up for a few seconds and goes up. And let's see what are, so there are a few other buttons, so it's not working. So we just have one button, which is a deploy toaster and nothing else. Okay, now we need to find out the secrets hidden inside this. We need to unravel the mysteries. But for that, we cannot do it right here because this application is not providing the information that we want. So now what we want now is the source. So for that, what we need to do is I'm just opening this application using an archive manager. So I've opened it and this is what I see. So just like we saw earlier, we have a few things here. Okay, I'm not sure why that part of the screen is not coming here. So I'll be telling you, there is the meta-inf folder which we talked about, which stores all the certificates. So if you can see there, little part, it's called cert.rsa. That's an encrypted file. It stores the certificate, RSA certificate. And the cert.sf. So basically, I talked about the signature, the digital signature. So this is how it is done. The digital signature will be stored here. And we also have the manifest.mf file, which references every single resource within the Android application. So we have each one of the elements within the Android application, like the XML files, the images, the PNG images, everything stored along with the SHA1 digest for each one of them. Okay, next we have the resources folder. So resources stores all the resources which are used inside the Android application. So all the PNG images, the icons are all stored here. And then we have the Android manifest.xml file, which, as we discussed, stores all the information related to the application, like which activity should be launched first, how long the activity should last, and how the overall process goes on, and the permissions that the application should be asking for, all those things. And the compiled resources as well. Now what we need here is the classes.dex file, because we need to reverse this. We need the code, and that is what we need here right now. So we need to reverse classes.dex to get the source code and see what is happening in the background. So let's extract classes.dex. Okay, I've got classes.dex here. Okay, now I'm going to rename this to toaster.x for convenience. Okay, so here I have the dex2jar, the tool. This is the dex2jar tool. I've renamed it to be d.sh. So I'm going to run this tool and extract the Java archive. So once we run this tool, we'll be getting the Java archive. So yes, so we've got the .jar file here from .dex. Now since we have the .jar file, it's pretty much easy from now, because now what we need is a Java decompiler that can build this Java archive. Now I'm using this Java decompiler called JDGUI. I've dropped the links in this slide, so you can check it out later. And so now I'm using this JDGUI. There are a couple of other Java decompilers as well. So here we have two packages. So this is my toaster.jar. So I have android.support package, which stores all the information related to the Android, the fragments and classes. This is auto-generated, so we don't have to be looking into this. So what is interesting to us is this particular package called Pico app 453.pico. Okay, so here we have the r.java class. So I said, so r.java class is it's a class that is used for storing all the APK contents with a particular ID assigned to it. So meaning, if you were to refer a particular part of the APK, suppose you want to refer one of the images inside the APK, then you wouldn't have to write all the package name, the class name, and the things like that. It would be really large to write those things. So what we can do is each of them is provided with an ID, and then we can define the ID over there. So r.class stores each one of the elements with a particular ID, unique ID. Right? So that is what r.java class is for. Now the last, this is the toaster activity.class is what is the most interesting, the one that we need. So let's look into this and see what it is doing. So we have a public class toaster activity, and then we have a string mystery, and what it is doing is it's a character array with a lot of numbers, and it is converting it into a string. Right? And it's storing in a string called mystery. Okay. So leaving them behind, let's see what else is there in this activity. So here we have the display message function, and it is doing toast.makeText. So that's what we saw earlier when we clicked on that button, we saw toast.makeText, and we saw this particular message popping up. And it's logging the data as well. Okay, we have the onCreate function, which rest of the things are not really very much of interest to us, because those are the generic functions that will be that are used in the Android activity classes. Right. So what we need now is this mystery string. So we need to understand what this mystery. There is something hidden in this mystery string. So this is what we need. So what I did was, anyway, this particular application is not doing it for me. So it's not showing what exactly that character array is and what it exactly means, because it's not being printed anywhere, or nothing is being done with that. It's just being declared over there. So what I did is I wrote a simple Java program like this, and I took the input. I declared two arrays, and one of the arrays stores all the numbers that we have got from that particular application. And then I'm printing the character value of each of these numbers. So I'm going to run this program. Okay, so this is what the string meant. What flag is, what does the logcat say? So we have actually got the string that we were looking for, the mystery that we were looking for. So that's about reversing the application and finding the secret. So this is a very much simple application which was purposefully made simple for study purposes. There are a lot of others out there which you can actually acquire and start finding out. So we have discussed about various things on Android security, application security, and we have seen how malwares could come into our devices. So now let's talk about some of the mitigation techniques for the same. So how do we protect ourselves from not being infected with malwares? So few of them would be, first thing, checking permissions. This has been told for a long time, and then installing applications from trusted sources alone, and using anti-malware apps. Probably I'm coining this term, anti-malware. So there are a lot of antivirus applications available on Play Store, but what we need those work on certificates, right? So what we need is an application that would work on permissions. So we have one of them which is called the Seraphim Droid. It's a project, it's an open source project still under progress by the OS community. So you can find the application on Play Store. You just have to install it, and it scans all the permissions that an application is using. So it will shortlist those applications which are using sensitive data from your device. So in case you have not looked into the permissions and you have installed an application without notice, then you might that might be useful as well. So I have left a few references if you want. So thank you so much. Sorry, anti-malware. Yeah, it's called Seraphim Droid. SERAPHIM DROID.
Any questions?
Okay, so it comes along with the Android SDK. Once you install the Android SDK, you have the emulator. So you can download any of the images that you like. For example, you can download KitKat or Lollipop or whatever image you want, and then yeah, you can install it on your device. It's available for all the platforms, Linux, Mac, and Android as well. I mean, Windows as well. So you just have to install the Android SDK.
How we can see the Smalley code for this Java code, and how we can modify that and recompile that?
Okay, so there are few tools available for this. One of them which we discussed was APK tool, which actually decompiles the .dex into Smalley code. You can view Smalley codes that are decompiled by APK tool using any of the text editors as well. But if you want in a more sophisticated manner, then you will have to look into other tools which are available online. There are few tools. I'm not really sure about those tools. There are like they come in a set. There are a lot of things that these tools do, and one of them is producing the Smalley code. So basically, it looks similar to the Smalley code looks similar to bytecode. So for one function, you will have hundreds of lines. It's not easy to understand and debug Smalley code. So that is why we are relying upon converting them into a jar file and extracting the class files. Yes.
So can an application download the bytecode and make it like?
Yes, sir. That was one of the vulnerabilities that started one of the easier attacks, because see, suppose we download a file from Android Play Store and it is a legit application, and it's a huge application. So what Play Store does is it won't allow you to upload APKs that are above 100 MB. The size keeps changing actually, but as of now it's 100 MB. Something above 100 MB cannot be uploaded to the Google Play Store. So what you do is you split the whole, say suppose you have 1 GB game, and what you'll have to do is you will have to split it into data and the APK part. So what happens, you will have to install the APK first, download all the data from an external server. So suppose if the person who has design that application, if he wants to install a malware into your device, it will be easy because next time when he produces an update, obviously you are going to update it because you got it from a very legit source, right? You got it from the Play Store. But the data is actually coming from another server. So in that case, you can actually put some code into your device, and that some malicious code could be injected in a very safe manner. Right? Nobody could be easily able to detect it. They are trying to actually find mitigation techniques for this as well. Thank you so much. Special thanks to Manapur sir and the whole Cysinfo Cybersecurity community for this wonderful opportunity.